You've used an AI, right? And you've probably had that moment where you just stop and think, how on earth is this possible? It feels like actual magic. But like any really good magic trick, once you learn the secret, it's actually kind of simple. And today, we are pulling back that curtain.
Okay, let's just rip the Band-Aid off and ask the big question right away. When you ask something like ChatGPT to write for you, what is really going on in that digital mind of its? Is it thinking? The way you and I are? The short answer? Not even close. And the reality is so much cooler.
So here's the single most important thing you need to get. For, decades, all software has been what we call deterministic. You write a strict rule, if this, then that, and the computer follows it perfectly, every single time. Generative AI threw that whole playbook out the window. It is probabilistic. It's not following a set of hard-coded rules, it's just playing the odds.
And this, right here, is the secret. That's it. This is the whole trick. At its very core, a large language model is just an incredibly sophisticated prediction engine. It looks at all the text it's just written, and it asks itself one simple question. Based on the billions of sentences I've read from the internet, what tiny piece of a word is statistically the most likely to appear next? It just does that over and over and over again, and poof, a sentence just emerges. This one simple idea explains absolutely everything, from its incredible creativity to its really, really weird mistakes.
Okay, but to really get our hands dirty with this stuff, we've got to learn the lingo, right? So let's do a quick run-through of the key terms you're going to see everywhere when you're dealing with AI.
First up, you hear this all the time, LLM. It stands for Large Language Model. This is the engine, the brain of the operation. It's a massive neural network, which is just a fancy computer system loosely inspired by our own brains, and it has learned patterns from just an unbelievable amount of text and images and code. And now, many of these are multimodal, which means they get text, images, audio, the whole shebang.
Next up, tokens. This one's a little weird, but super important. AIs don't really read words the way you and I do. They break everything down into what we call tokens, which are just common chunks of characters. So a small word like cat might be one token, but a more complex word like unhappiness could be 3 tokens, on, hap, and innis. Why does this matter? Because almost everything in AI, from its limits to how much it costs, is based on tokens, not words.
All right, next term, the context window. The absolute easiest way to think about this is as the AI's short-term memory. It's the total amount of tokens, your prompt plus its response, that the model can hold in its head at one time. If any information scrolls past that window, it's gone. Poof! The AI has absolutely no idea it's ever even existed. And just to give you a sense of how wild this has gotten, a model like Claude 3 has a context window of 200,000 tokens. That is enough to fit an entire book, like all of Moby Dick, into its working memory all at once. I mean, just a few years ago, that was pure science fiction. Okay, the prompt. Now you might think this is just what you type into the box, but it's so much more than that. The prompt is how you program an LLM. Seriously, crafting a really good prompt isn't just about being polite. It's a legitimate skill. It's called prompt engineering, and it's all about guiding those probabilistic guesses to get what you want.
And last but not least, temperature. Honestly, this might be my favorite one. Just think of it as a creativity dial. If you set the temperature to 0, you're telling the model, always pick the absolute most predictable, most likely next token. It's going to be super consistent, maybe a little boring, but great for factual stuff. But if you crank that temperature up, you're letting it pick wilder, less likely tokens. It gets creative, random, and sometimes a little bit weird.
So, okay, we've established that the AI is basically a superpowered guess-the-next-word machine. But how does it know which word is a good guess? How does it understand meaning and relationships across a huge document to make that prediction? Well, the answer to that question changed everything.
Well, back in 2017, some researchers at Google dropped a paper with a title that was frankly just epic. Attention is all you need. This paper introduced something called the transformer architecture. And that architecture is the foundation of every single major AI model you use today. GPT-4, Claude, Llama, all of them.
Let me show you what I mean. Just take a look at this sentence on your screen. Pretty simple, right?
Simple enough, but hold on a second. How did you know that it was the cat? Your brain just did it. You didn't have to think about grammar rules. You just instantly knew the relationship between those words. Your brain just paid attention to what mattered.
Well, that automatic connection making you just did, that's exactly what this transformer architecture taught computers to do using a brilliant mechanism called self-attention.
As the model reads a sentence, for every single token, it calculates a connection score to every other token. It learns which words need to pay attention to other words. So in our sentence, it learns that it has a massive connection score to cat and a near zero connection to Matt. And by building this giant web of connections across the entire text, it starts to understand context. It's brilliant.
So we have this incredible architecture, but a brain is useless without knowledge, right? So how do we actually teach it to be something useful, like ChatGPT? Turns out it's this really cool two-step process. Phase 1 is pre-training. This is the all-you-can-eat internet buffet. We basically unleash the model on a huge chunk of the public web and tell it to do one thing: get really, really good at predicting the next token. After doing this trillions of times, it develops this deep, intuitive grasp of language, facts, and even reasoning. But that raw model is kind of like a wild animal. So then comes phase 2, fine-tuning. This is where real humans come in and basically give the model feedback, rating its answers and teaching it to be helpful, to follow instructions, and to not be harmful. This is what turns a raw text predictor into a polished, useful assistant.
Okay, that's a lot of theory. I get it. But why does any of this actually matter to you when you're just trying to get an AI to write an email? Well, because understanding this stuff, it gives you control. Think about it. Now you know your prompt is setting the starting point for a game of probabilities. If you give it a lazy, vague prompt, you're basically telling it, hey, any of these billion paths is fine. But a great prompt, that's you carving out a narrow, specific path right to the high-quality answer you're looking for.
And this finally explains hallucinations. The AI isn't trying to lie to you. It literally can't. It has no concept of what is true or false. It's just a pattern-matching machine generating what is statistically plausible based on what it read. So if the most statistically likely pattern happens to be a made-up fact that sounds convincing, well, that's what you're going to get.
So now you can make way smarter choices. Next time you've got a massive 200-page PDF to get through, you'll know to ask, hey, what's this model's context window? Can it even handle this? If you're building a chatbot for customer service, you'll know to lock that temperature down to 0 for consistent answers. And if you need some wild ideas for a marketing campaign, crank that temperature up and see what happens.
So yeah, maybe the magic trick is revealed, but what you're left with is something way more powerful: genuine understanding. The AI isn't thinking, it's predicting. And by knowing the simple rules of its game, you can become a much, much better player. So the only question left is, what are you going to build with it?